Angara is a whole family of light, medium, and heavy class rockets with an oxygen kerosene engine, created based on a universal rocket module. The first one to prepare for a trip into orbit was the light rocket carrier Angara 1.2 PP. The main goal of the launch was to check the engines and rocket systems, including the navigational and telemetric equipment, as well as the proper functioning of the space rocket complex components. The cargo layout mimics the head of the rocket payload, and having passed 5,700 kilometers, it will land in a specified area of the Kamchatka Peninsula. It was here in this spacious, bright room that the most important stage, the final assembly of the rocket, is held. This assembly test body has all the necessary equipment for the independent testing of missile units, its assembly, and subsequent loading onto the transporter. The entire history of the Angara is like a reflection of Russia's recent history. Conceived as early as 1992, the rocket passed through the echo of USSR's collapse, the criminal 90s, and even the economic crisis of 2008. And now the Angara project comes to the finish line, holding its first test start. This is the layout of Angara, but not just an imitation, but a complete missile, able to send a satellite into orbit if needed. Alexander will tell me about its components and the principles of modular assembly. Yes, indeed, this rocket carrier was built according to a modular assembly principle. The rocket consists of a Unified Missile Module 1 and Unified Missile Module 2. If necessary, the missile data modules can be arranged into a light-class rocket carrier, as we see now, and also into a middle-class or heavy-class launch vehicle. Angara 1.2 PP consists of a first stage, second stage, nose fairing, payload weight layout, and booster. By adding universal rocket modules, URMs, we get a whole range of rockets from light to heavy class capable of performing a variety of tasks for the needs of military and space. One launch pad for light, medium, and heavy rockets, only thanks to modularity. Yes, the system is the same in the starting complex and the processing facility. No changes or additional preparation when changing the rocket would be required. Each URM includes a propulsion system, an instrument compartment, tanks for fuel, and an oxidant. So URM is basically a rocket. That is, the rocket Angara will consist of several small missiles roughly put. Yes, each block can be presented as an independent missile. Angara's universal modules allowed us to standardize the production, and now the cooperation of the Russian enterprises has unified blueprints and technology. This is what ultimately reduces the cost of each startup. The use of Russian scientific and industrial potential protects the Angara from the political will of other countries. Quite a logical step if we remember that the client is the Russian Ministry of Defense. The lead developer of the missile is the Krunichev Scientific Productional Center, one of the largest branches of which is in Omsk. At the Polyat Industrial Association, URMs are assembled for the Angara. First, they work with a preform for the rocket fuel tank. They mount the technological rings and other accessories for loading and docking. Next, there is a connection of the longitudinal joints by friction welding. Today, this is the most modern technology based on the principle of friction between different surfaces until a complete merger. In contrast to conventional welding, friction prevents thickening. On this machine, all the other parts of the missile, including the bottom of the fuel tank, will also be lapped onto each other using this method. Next, the bottom is welded to the tank, and so we get a tank for the URM-1 oxidant. With the help of technological rings, the tank is turned over to a vertical position in order to check for leaks. This is followed by hydro testing. The space of the tank is filled with liquid, after which they monitor and inspect for leaks. Then the tank is driven into a separate chamber to install the inner tank devices. The sterility and purity of the camera is key to the safe and trouble-free operation of the engine afterwards. The thing is, if the fuel will have technological impurities from the factory, a rocket engine fire is impossible. Apart from inner tank devices, expendable pipe and fuel level monitoring sensors are also installed into the tank. The URM-1 has separate tanks for oxygen and kerosene. After installing the inner tank or dry compartment, the engine compartment and the adapter ring for the subsequent installation of the propulsion system are secured. After closing the engine compartment, URM is ready for final assembly. The only thing that remains is to establish a trunk line through which the oxidizer enters the engine. Fuel is poured directly. After being laid down on the railway unit, the URM is sent to Moscow to the Khrushchev Scientific Productional Center, and then, after all the independent tests, it is sent to an unassembled state to the Arkhangelsk region, where final assembly will begin. Meanwhile, in Plessis, the fully assembled Angara is preparing for loading. First, the installation and assembly calculator conducts the assembly of the circuit loading. Then the mounting is moved and manually with the help of special platforms. The lapping is ensured. The most important and responsible operation is the lifting and transportation along the hull as well as the installation on the mounting unit. Now we see the process of loading the rocket onto the installer. Next to me is Mikhail, who will tell me how the loading happens. Hello. Hello? We are now in the processing facility that prepares the family of Angara launch vehicles. Right now, what you're seeing is the final step of this technological process. The first launch booster completed all the necessary tests at the processing facility and is ready for start. This operation makes this rocket ready for launch. The military calls this process overload. I fully agree with them. When 18 tons of weight, that's exactly how much a dry rocket weighs, flies over you, you automatically start to feel like a dwarf in the world of giants. At the same time, in order to successfully install the Angara on the conveyor, all work must be completed with a tolerance of less than a millimeter. Already the next day, the combat crew will take the rocket to the launch pad, where it will pass all required tests and will be prepared for launch. The next morning began with the construction and formulation of the problem of transportation of the Angara. The escort service, together with combat duty assignment, took their places according to protocol. Then the locomotive for docking came up. After checking the connection, our train started moving. We ought to hurry. There's less than 57 hours till the launch. It's about 7 a.m. now. I terribly want to sleep, but all services and combat duty assignments are long in place. Together, we'll participate in the Angara's transportation to the launch pad, and I can finally feel like a true space loader. Igor will tell me how the whole operation is going. Hello? Hello? Igor, why are we moving at such a slow speed? Such are the requirements for transportation. The speed should not exceed 5 kilometers per hour so that we can safely transport a product that took a long time to prepare for combat assignments at the technical facility and guarantee it the safe and sound start of its trials. In the transport group is the diesel locomotive that pulls the entire train. Further, we see the platform through which the locomotive and the installer are connected. The Angara complex has 2 installers, for the light and the heavy launch vehicle. The weight of ours is more than 100 tons. The installer's huge mass gives it a very low ground clearance, so the dimensions of transportation are 5 meters from the main track. So the dimensions of motion are 10 meters. That is why there are no structures in the way to provide a 10-meter distance. Don't forget the very low ground clearance. All the railroad crossings were forced to be aligned, taking into account the clearance of the heavy and light class rockets. Are you saying the railroad was specifically rebuilt for the installer? The tracks and adjacent roads, railroad crossings, everything was aligned according to the installer. Prior to this, we repeatedly rolled it, confirming all of the dimensions, after which the construction companies performed work on retrofitting these crossings. This road here is the so-called special way number 1. It is special because it has features needed only for the transport of a space rocket from technical complex to the launch pad. Our railway tour of the Arkhangelsk region continued. In total, we completed 3 kilometers. The changing of the weather worried us, and although transportation does not depend on weather conditions, we weren't really wishing for heavy rain. The interaction between railway workers and combat soldiers was ensured by eye contact or radios, reporting the successful completion of waypoints. Ahead of us was another 4 kilometers of the taiga. Along the way, we saw a few checkpoints. Each point has everything you need for the emergency repair of the tracks or a stuck train. In the open areas, my glance rested on the fences that hide the way number 1 away from prying eyes. Meanwhile, the locomotive began to slow down its initially not so high speed. This is where the locomotive stops and continues its motion only with the tail compartment forward. The weather began to change for the better. Even the sun came out. At the launch site, the installer must enter first to provide the necessary docking units, and the locomotive could be sent to the depot. The track has a special configuration and is built precisely for these tasks. The position of each track and railway sleepers were measured virtually by hand. Such a load and weight excludes sharp turns. We're passing some sort of hangar. Is it a repository or is it some kind of gate? What is it? No, we've entered the universal launch pad, the starting position. And the first building we encounter along the way is a complex of low-pressure filling tanks for the Breeze M booster block of the Angara A5 heavy-class space rocket. The construction part is not yet finished. It's still going on in its second stage. And in this case, we have a little tradition at spaceports that has taken root at the Angara as well. In order to commemorate the beginning of some stage of work that's important and interesting, we put a coin on the rails and we press it with the installers. I want to give you such a coin. Thank you. This, in memory of this significant event, the transportation of the Angara rocket to its first universal launch facility. Our train was greeted by a large number of people. Military and civilian experts waited for 2 hours for the Angara to appear on the horizon. The Angara's high-speed train is arriving on the first way. Everyone goes to the greeting dock. Next, the locomotive will unhook from the site and the installer will cover the last 4 meters with the help of its own electric drive. The most important part of the transportation is the docking of all electrical and hydraulic power units with the launch system. To do this, the installer reaches the control points and makes runs over the carriage of the automatic docking unit. This completes the transportation process, but this is only the first step of a ladder abutting straight into the sky.